To another day of physics conversation with myself and two students, one from Brown University Rep, one from New York University Human Isaac. Today, what we're gonna do? We're gonna do 2016 Regents physics from 51 to 85 short response problem. Isaac, can you read the first one?
All right. 51 and 52. Calculate the magnitude of the net force acting on the box. So I'll work.
Okay, all right. So first, we're gonna have to find the net force.
Yes.
All right.
Magnitude of the net force.
So you have a box, right? What is the mass of the box?
2.5 kilograms.
2.5 kilogram. What is the acceleration and what direction?
To the right.
I don't think you're given the acceleration.
It is
given.
given.
2 meters per second
What
squared.
is the applied force?
15 newtons.
And we have to find the what? Force of friction or net
Net
force?
force.
Net force.
Okay, let's first find the net force. Rep,
Yeah.
what is Newton's second law?
F equals ma.
All right. So F equal ma. Isaac, can you tell me what direction the net force acting? X direction or Y direction?
It's acting in the x direction.
How many forces you see acting at the X direction?
Just 2.
Fa minus Ff is equal to ma. So yes.
I don't think we have to do that. Can we just multiply m by a?
M by A, okay. So we can say net force F net is equal to M is 2.5, A is 2. So 5 meter per second. 5 newtons. Yes. All right. That is problem what? Problem number 51?
51 and 52.
Oh, that's it? 51 and 52. Finding net force?
Yeah.
Okay.
51 is writing the equation and 52 is getting the result, I think.
Is there any other way you think it should be done?
I don't believe there's another way. You
Okay.
can't find the force of friction.
But in the Regents physics, you're gonna lose point for
Yes, not
massive
including
calculations. Yeah. So it has to be mass 2.5 kilogram and acceleration 2 meter per
second
second
squared.
squared. Now 5 kilogram meter per second squared, and you can say this is 5 newton. Yeah, that is right. Okay, what is then 53?
Determine the force of friction on the.
Okay, so you want to find this force of friction, right? So again, net force at the x direction is equal to
Fa minus Ff.
ma, and which is 5 newton, right? Is that right?
Yeah.
Okay, so how many forces acting at the x direction?
Two.
Fa minus Ff is equal to 5 newton.
Yeah.
All right,
Fa is 15.
we want to send the ff to the other side. So Fa minus 5 newton is equal to Ff.
Mm-hmm.
So Fa is how much?
15.
15 newton minus 5 newton is equal to
10.
Ff. So Ff is how much?
10.
Ff is 10 newton. All right. We're done with this one, right?
Yeah.
Okay, let's go to the next one. Raf, can you read, Brown, can you read the next one?
Yes. A ray of light is traveling through a mineral sample that is submerged in water. The ray refracts as it enters the water as shown in the diagram below. Calculate the index of refraction of the mineral.
Okay, so Isaac and Raf, I have millions of questions for you. What is the name of this line?
That's the boundary.
What is the name of this line?
Normal.
What is the name of this line? If you want to call it line, you can call it anything else.
It's the incident ray.
I'm gonna give you two angles. This is what is this one?
27.
27, and this
27
is
degrees, 63 degrees.
Isaac. Which one is the incident angle?
27, because it's measured right from the normal.
Good. All right. This one is closer to the normal or away from the normal?
That's 41 degrees.
Yeah,
It's
so it's
away
closer.
from the normal.
Right?
Yeah.
Oh, yeah, that's
Why away from the normal? Because this is big N
Less.
and this is
Less n.
small n.
Yeah.
I never heard less n. Okay. What is the angle? Which one is the angle?
41 and 49.
So Isaac, which one is the angle? 41 or 49?
41 because it's measured from the normal once again.
Good. All right. Excellent. So what do you know that when things go from small n to big N, the incident ray is bigger than?
Refracted ray.
And when it goes from big N to small n?
It's the other way around.
Other way around. Okay. All right. So refracted ray is bigger than?
Incident.
Okay,
Yeah.
let's see. N1 sine theta 1 is equal to N2 sine theta 2. N1 is what? The big one, right?
That's what we were trying
So,
to find.
right. So then I'm going to give you N2, which is 1.33, because N2, this is water, right?
Mm-hmm.
Water. Index of refraction for water is 1.33.
1.33.
Sine 41. Is that right?
Mm-hmm.
Yeah.
And Isaac, what is this one?
It's a mineral with unknown N2.
Sine 27.
Oh yeah, but
What is N?
wait.
Yes.
N is
We don't know
1.92.
N2.
1.92.
We
We
know,
do know
27.
N2. It says 20.
That's the incident angle.
Yeah, incident
Yeah.
angle. This is incident angle.
No, I'm talking about the index of refraction.
This is water. Water
This
is
is water.
1.33.
No, this one.
Yeah, that's what we're trying
That's
to
what
find.
we try to find.
Oh, okay. I see. That shows. Yeah, I see. Sorry.
Okay, so what is the index of refraction?
Is 1.92.
1.92. Isaac, what is the SI unit for 1.92?
None of the
Good.
above.
If there is a SI unit, it would be meter per second over meter per
Second.
second. Good. Would you be able to tell me what medium is this one?
That's a mineral, but we don't.
Look at the page number 2 or 3.
Oh, come on, man. 1.92 zircon.
Zircon. How do you spell that?
ZIRCON.
Like zirconium.
Now, I have a tricky question for you guys. At what angle the zircon, alright, what angle zircon behave like a mirror?
Oh, so the critical angle.
Isaac, come, you do it. Find the angle zircon behave like a mirror. And first do the diagram.
Okay.
This
So-
is extra problem.
So essentially, what we want is the critical angle, i.e., the angle at which, if we send a ray from
Different color, please.
if we send a ray from the mineral into the water, it's going to look like this. Yeah.
No,
Yes, it's going
it's
to.
90 degrees with respect to the normal.
Oh,
Critical.
sorry. It's going to look like this. Sorry. Measured from the.
Okay.
Had the same misconception of measuring from the wrong place.
So where is the critical angle? Yes.
Give me 1 second.
Yeah.
Jeez. So this is theta critical, and as you can see, this is 0 degrees right here. So
This is not 0 degree. Calling it 0 degree would be wrong.
I'm talking about this angle, not the angle to the incident.
Whose angle is 0 degree?
This angle right here, the one that's normally below the ray.
Yeah, but
I don't know
you
whose
have to
angle is
measure-
0 degree over here.
if you
This
measure
one is
from the
90
normal,
degrees.
Okay. Which one is
Is that
0
good
degree?
enough?
90.
It's the one under the ray. It's not visible because it's 0 degrees, so that means it's parallel. Okay, geez.
Why we have to mention that, by the way?
Okay, so theta 1 equals theta c, and theta 2 is 90 degrees. So that means we get N1, which is a 1.92 sine theta 1. It's equal to, it doesn't matter which on the other side because sine 90 degrees. This one is going to be 1, so this is N2, which is 1.33. So you just get theta c is equal to arc sine of 1.33 over 1.92.
How much is that?
43.8.
All right, Raf, can you do at what angle you're gonna have the total internal reflection?
Oh, it's the same angle.
No, come. No, it's not same angle. Not same
Oh,
angle.
it's greater than.
Yeah, greater than. So can you show how the graph look like for total internal reflection?
Yeah. So. Okay, so for total internal reflection, it behaves.
No, do the graph over there below.
So for total internal reflection, the zircon will behave just like a mirror. So here's your incident ray at some angle theta I, which
Not
is greater than
not greater than critical angle.
43 degrees. Yeah.
Okay.
And it will reflect back theta R equals theta I. So,
Okay, good. All right. Anything missing, Isaac, from this problem? Can you double check? Is it okay? We can move on.
No.
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 Okay. So we're gonna move to the next problem. And next problem will be number what?
56 and
Uh,
57.
Is Isaac done?
Okay.
Is Isaac done?
A ball is rolled twice across the same level laboratory table and allowed to roll off the table and strike the floor. In each trial, the time it takes the ball to travel from the edge of the table down to the floor is accurately measured. Please neglect friction.
Okay. So Isaac, so let me draw the scenario. Scenario one, table A. Scenario B, table B. Scenario A, they said that it times takes 0.393 what?
391.
391 sec. And they ask you to find this one. Given this condition, here the ball roll much faster. Ball falls double as velocity as this one.
Okay.
Double. When you double the velocity, the common thing people have misconception that the time takes less time.
Yeah.
So Isaac, can you discover that? Help the student find their misconception. What do you mean from proving that both take the same time? We're not going to write that. 0.391, we're not going to write that. Erase that. We're going to discover that both take the same time.
All right. Let's.
Height and this height are the same.
Yeah. So we're not given it, so let's just assume it's some distance dy. Now let's talk about the kinematic equation. Dy equals vy t plus half at squared. So if you solve for time in this equation,
Hold on. Can you write Vy for both case?
in this case vy is 0 once we fall off, and vy is also 0 here once we fall off.
Vy is 0 for how many moment of the time?
Right until it starts falling.
Only at one moment of the time Vy is 0?
Yes.
Okay, only at one moment of the time?
Yeah.
Okay.
So vy initial time plus half at squared. You'll notice here that vx initial is not
In the equation.
even a variable. So that means that changing vxi should have absolutely no effect on the distance traveled over time and thus the time it takes to hit the floor.
So instead of 5, if we even change it to 500, is it still going to take the same amount of time?
Of course. It's always going to be 0.391 seconds if we just keep tinkering around with Vx, because in reality, that's not a factor to how much time it takes.
So we calculate what the height is.
You can't find that.
Yeah,
Oh, wait.
you can.
You can.
Times plug it in.
That's right. So, is that another question?
4.9. Oh, is
Okay.
that another question?
That's 56 to 57.
Okay. So we're going to help him out.
It's okay.
Okay.
So, right, and you have to put units, otherwise the Regents monster will be very mad. 0 meters plus 9.8 meters per second squared times time squared is going to be 0.391 seconds squared. So then,
0.75.
really?
Yeah, I did it.
No, it's exactly
It's
0.75.
0.749.
Yeah, 0.75. They accept those rounding. This is 0.75 meters, so that must be 0.75 meter as well.
Yep.
Any other thing we need to find for this problem?
No, we did 58.
We did, okay.
That's comparing these two.
Okay, and 57 was? 56, 57 was? Height?
Yeah, height.
Okay. Alright. Rav, can you read the next problem?
Yeah. A towing airplane flies clockwise at a constant speed in a horizontal circle of radius 8 meters.
What number is that?
59 and 60.
Okay, so I'm gonna ask you millions of questions when we solve 59 and 60, and this is a circular path. I'm gonna draw the plane at how many location? Location 1.
4?
This dot represent the plane. I'm gonna put the plane over here. I'm gonna put the plane over here.
Not artistically gifted.
And I'm gonna put that's right. Put the plane over here. What I want you to do, Raf, you're gonna draw AC at 4 location, and Isaac, you're gonna draw No, I'm not gonna answer the question now.
Oh, what does AC stand for?
Centrifugal acceleration.
Thank you.
And Isaac, you're gonna draw the velocity vector at 4 location. So Raf, first you're gonna draw the acceleration vector at 4 location. Can you write what is AC means as he asked? It's not air condition.
Centripetal
One of my students said AC for
Air conditioning.
Yeah.
Yeah.
I would think that way too.
Okay.
What about alternating current?
Goes to the center.
So Isaac, what are you gonna do at 4 location? You're gonna draw speed vector.
All right.
I'm sorry, speed is not a vector, velocity vector.
So let me explain a little bit more in depth. So let's say we were at location 2, and then we wait for 1 second, and it goes to location 2 prime.
Do it clockwise so people would understand it because
Oh,
do it
velocity.
at the 4.
Yeah, do it clockwise.
Do it on the 4 dots.
No, please. Okay,
First draw the velocity vector and then explain.
fine, sure. So here's the velocity vector at 2. Here's the velocity vector at 3. Here's the velocity vector at 4. And lastly, here's the velocity vector at 1. Now let's explain. So let's say at 2, we wait for 1 second, and then it goes to this location, 2A. Then, let's say we move it back to 2, and we set it off, and then we wait half a second, and it goes to location 2B, and a quarter of a second 2C, etc. Now let's draw a line between this point and 2A. Looks like this. If we draw it between this point and 2A.
Yeah, in fact, lots of students draw the velocity vector like that.
Yeah. So essentially, you have to think about what it's approaching at the end, which is this tangent line to the circle.
So how? Okay, over the time, the velocity vector, just lots of students draw this. Okay, how you can say this is also right, but in different context.
Well, this is essentially the average velocity over time.
Good.
So, like, the average velocity from
Good.
here over to here.
Average velocity. This is not an instantaneous velocity. What we are looking for is the instantaneous velocity.
Yeah.
Instantaneous velocity at exactly location 2, not location 2.1, not location 1.9.
Mm-hmm.
Okay, so Isaac, you find the velocity.
Oh, all right.
The radius is 8 meters.
And
the acceleration is 25 meters per second.
All right, 8 meters, and we're given that the magnitude of this acceleration is.
Oh, by the way, before you do that, which one is correct answer? Is location 1, 2, 3, or 4? Which one is correct? Not all of them correct.
What do you mean?
The question is state the direction.
No, let him read the problem.
What do you mean correct?
Yeah, let him read the problem.
61.
Oh, state the direction of the velocity of the airplane when the acceleration of the airplane.
It is the incorrect one.
All right. First we have to remember our handy acronym: never eat soggy waffles.
Oh, it's also wrong.
So that means that south is in this direction. Now let's figure out which of our vectors has the acceleration pointing south, and that's going to be this one right here. So that means that location 2 is the place where we want to be, and now we have to find the direction of the velocity, which is this ground vector. And as you can see with our little cardinal, we have that it's traveling east. So east is our answer.
All right, very good. And now find the magnitude.
All right. So finding the magnitude, just using this equation that Refast wrote earlier, we get v squared over r, which is equal to, well, we're trying to find the velocity, right?
Absolutely.
So now let's just rearrange this equation to get v is the square root of ac times r. So the square root of 25 times 8, which should be
14.14.
Thank you.
Not 141.4.
Oh wait, yeah.
14.14.
You're right. Wrong spot for the decimal. Thank you, Refast.
Okay, so that takes us problem number what?
62.
62. Who is reading it?
I'll read.
Okay.
Oh. Can you read this one?
Yeah.
Yeah,
The
so
graph-
can I read?
Okay.
Okay. The graph below represents the speed of a ball rolling down a straight incline as a function of time. So first of all,
What is it? What is the graph?
Speed versus time.
yeah.
Speed versus time.
Should I draw it?
Yeah. If you really want.
Okay, so let's see. To make it look a little bit more accurate, we have this 1, 2, 3, 4, and 5. And then we have this line 1, 2, 3, 4, 5, and 6. This is speed. And remember, this is just a magnitude. It doesn't have any direction. And then here we have time. So then our graph is going to look a little bit like
What is the name
Yes.
of this slope? What is the name of this slope?
this is what we call acceleration.
Good.
No.
It's the magnitude of acceleration.
Yeah, sure. Yeah, same thing.
How is it not acceleration?
Speed versus time.
Okay.
Yeah. All right, go ahead. Finish it.
Calculate the distance the marble travels in the first 3 seconds.
All right. So
Shade the area under the graph for 3 seconds.
that is one way to do it, certainly.
The only way to do it.
No, it's
No,
not.
there are other way. D is equal to VAT plus. But this is the most famous way.
All right. So we don't want to confuse people here. So after this, I'm going to use the vanilla approach. So as you can see, this triangle right here, this area under the graph, you'll learn why in your calculus class. This area under the graph is going to be the distance traveled over these 3 seconds right here. And as you can see, since this is a straight line, that means we just have a right triangle. So we have,
You can ask us what would be the formula for right angle triangle.
well, it's given in the reference table.
Good.
So we get the area is half times the base is exactly 3. The height is exactly 4, is it? Yes.
Mm-hmm.
So that means that our answer is 6 meters. Now let's show a different way to do it. Well, it's actually the same, but it's a little less confusing. So distance is v naught t plus half a t squared. Now, since we have a straight line, we can assume acceleration is constant, which allows us to apply this equation. So our v initial is 0, so we can forget that, times 3 seconds, plus half a, what's the acceleration? Well, we just have to find the slope over time, which is going to be rise over run, or 4 divided by 3. And then the time is just 3 squared. So we get 0 plus half times 4 over 3 times, I'm sure you know by now, 3 squared is 9, which just reduces to 2 times 3 or 6 meters.
Is there any other thing they ask you in this problem?
Let me see. Oh, what quantity is, no, never mind. We
Okay.
did that.
Oh wow. So very nice.
The next one is another graph, so we have to draw it.
All right. Stefan, can you read it first?
Yes. The graph below represents the relationship between weight and mass for objects on planet X. Determine the acceleration due to gravity on planet X.
All right. So weight and mass. Okay.
Weight
You
versus
yeah. You want to do it? Go ahead.
Okay, let's go really fast.
Okay, so we have a plot of weight versus mass. Okay, weight on the y-axis, just in units of newtons, and mass on the x-axis in units of kilograms. And we have to find the acceleration.
Lots of time. My students think that weight and force are two different things.
Yes, weight and mass.
Weight and force are two different things, but weight and force are the same thing.
Oh.
Well, it depends what force you're talking about.
Okay.
Gravity and weight.
Yeah,
everything.
that's right.
So, okay, great. So we just need
Hey, no,
2
there's
points.
there's
on
no
line.
12 on the mass axis. I think you're thinking of 6.
Oh, sorry.
Yeah,
No,
you
okay.
swapped them up.
6. This is 12.
And
Is that right?
those don't
Yeah.
even line up. It's 4 and 12.
No. Oh, 6 and 18. Right. 6 and
Yeah.
18. 6, 18. Okay, good.
Okay.
Alright, so you want to use the F equal MA?
Yes.
No,
Actually, no. We can just
Rise over run.
we know that weight is mg. So if I know the m and I know the weight, then I can plug this in. Weight is 18.
Yes.
Mass is 6. So
G.
on this planet, yes, g
So
is gonna be much less than Earth.
3 meters per second squared.
is there anything else they wanted to find in this problem?
Doesn't look like it.
Okay. So next problem.
We are now in part C.
So Isaac, can you read it quickly?
Okay. Oh, what time is it? Oh. A hiker starts at some point P. Okay. A hiker starts at some point P. Okay. And walks 2 kilometers due east and 1.4 kilometers due north. The vectors in the diagram below represent these two displacements.
Wait,
Okay,
we need
Isaac.
a ruler.
No, okay. So one of my students did it this way. Did it this way, and I gave him 0. Y over x, and tangent is tangent minus 1.4 over 2, and he wrote 35 degree, and I gave him 0, although it is 35 degree. So now which way you will do it?
Why?
Using a protractor.
Okay, good. This problem. They don't want to check your math skill. They want to check your measurement skill. All right. So please do not do it by math. Do it by measurement. Okay, Isaac, do the step number 1.
All right.
How is he gonna do that?
Oh no, I mean pretend like I'm gonna give him practice. Okay.
Oh, but step 1 is using a ruler.
Yeah, I'm gonna give you a ruler and protractor. Come.
Okay. Ruler and protractor. Thank you. All right. So let's see. So determine the scale used in the vector diagram. Now the correct answer would be the one used right over here. Over here, we can determine it's 5 centimeters long.
So right,
So
2
5 centimeters is 2 kilometers on the scale.
All right.
Now let's just make sure our observations are correct by doing the same thing. And over here, we can see that 3.5 centimeters corresponds to 1.4 kilometers.
So can you tell me 1 centimeter is how many kilometers? How many kilometers?
Well, simple question. It's just going to be 0.4 kilometers.
For both cases?
Yes.
Good. All right. Now let's go. Now let's go to the next thing.
All right. On the diagram in your answer booklet, we're not going to use that.
You're gonna use this booklet.
Okay.
By red pen. Exactly by red pen.
Gotcha. Use a ruler to construct the vector. By the way, don't bring a floppy ruler like this to the actual exam. Use a sturdy ruler so your lines are straight.
Put a dot here, put a dot over there.
Okay. A dot over here, a dot over there. And all we have to do is just connect them by holding firm, making sure no flops happen.
That's wrong. This is not a vector. Make it a vector. Okay, that's also wrong. Put the angle.
Wait.
How's that?
Put the angle that you're looking for.
But no, that's not what the question is
That's
asking.
fine. It's still put the angle that you're looking for.
So we wouldn't lose points though. So
Yeah,
I'm not wrong.
Come on. I put the angle that you're looking for. Put X or theta.
Okay, so this is theta.
Right. Now solve the problem.
Alright, so we're not even going to be doing 69 yet because we still have one more. Determine the magnitude of the hiker's resultant displacement. But
do it by centimeter.
Yeah, we're not going to be using the Pythagorean theorem.
No, you cannot.
We're just going to have to use this ruler to experiment.
It is 6 centimeters.
And yeah, 6 centimeters.
Is that centimeter or millimeter?
No, centimeters.
The little divisions are millimeters. The
Oh.
smallest incisions are millimeters. That's why it's marked like that.
6 centimeters. So write 6 centimeters. You can do math over here so students see it by red pen.
Let's do it over here.
No. Do it over here.
It's
Okay, 6
more
centimeters.
visible. All right. And if you're not feeling sure, you can verify it with math.
No math.
I can't verify it.
No, they don't want to. They want to see your measurement scale. So I cannot teach the wrong thing.
Okay.
Okay, 6 centimeter converted to the kilometer. Go ahead.
If you convert this to kilometers, we just get 6 times 0.4.
No, do it legal way. Times, put the centimeter on the bottom, kilometer on the top.
Okay. But that's not even the right conversion scale because some people are going to put like 10 to the 6 kilometers in 1 centimeters in
This
1
is not
kilometer.
even kilometer. Okay.
No,
Centimeter,
centimeters
okay.
into.
All right. No, do it other way. 6 centimeter
All
times.
we have to do is multiply this by 6 and this.
Okay, go. But do it your own way.
6 centimeters is 2.4 kilometers. That's it.
But some student would need to know. Can you please give it to me? 6 centimeter times. You want to cancel centimeter, and you want a kilometer answer. And what is the ratio you discover? 1 centimeter is 0.4. Centimeter cancel. 6 times 0.4 is 2.4.
There we go. Using a protractor, determine the angle between the east and the hiker's resultant displacement.
Since you
East is this cardinal, please.
Yeah.
East is this cardinal direction, so that's the exact way that this 2 kilometer displacement is pointing. So we can use that is essentially a baseline for which direction.
This line can
Then
be okay.
we just want to figure out which way this red arrow is pointing. So I'm going to do crudely by drawing on the protractor, and it looks like it's at about 35 degrees.
Okay.
So that's
So
what
write it down. If you write 35, that would be wrong. You have to write 35 plus minus either 1 or 2. Yeah, that uncertainty. You have to agree that you are not perfect.
In which a figure in the open box is pushed down, compressing a spring. The lid of the box is then closed. When the box is open, the figure is pushed up by the spring. The spring is compressed 0.07 meters by a force of 12 newtons. Calculate the spring constant.
All right, Raf, you're gonna do it. What do you see that this spring in the box is compressed by how much? 0.07 meter, right?
Meters, yeah.
Okay, applying how much force?
12 newtons.
If you open this one, what happened? This is gonna go
Jumps
up. You want to find, is there any
constant.
potential energy due to spring here?
Yeah.
Go
course.
find it.
Yeah. Okay.
Isaac, you can help me with the calculator.
Looks like he's taking the calculator for
No, don't take it. It doesn't look professional.
Okay, so
70, 71, you need to find what?
spring constant.
The spring constant. Go ahead.
Okay, so Hooke's law says that F is equal to kx. Okay.
Okay.
Okay, so force here is 12 newtons. K is what we're trying to find, and x is 7. So that means
Isaac, what is it?
Let me see.
Should be 170 newtons per minute.
Very good.
Okay, good.
All right. Next thing you need to find, calculate the total amount of elastic potential energy stored in the spring.
Okay, great.
How much potential energy here because it's compressed.
Right. So the potential energy.
No, don't use this one. PES.
Okay. So the potential energy stored in the spring is 1/2 kx squared. So 1/2, we just calculated k, right?
Mm-hmm.
And we know x, which is
It's 0.42
0.42 joules.
Yes.
0.42 joules. All right.
0.42.
Isaac, do Isaac next. Isaac, you read the next one. 74.
Identify one form of energy to which the elastic potential energy of the spring is converted once the figure is pushed up by the spring.
Okay.
So elastic potential energy converted to what?
It might be converted to gravitational potential energy because the jack in the box is going
Very
upward.
good. Okay, that's one example.
It's also converted to kinetic energy because the spring is moving,
Very
and
good.
it might be converted to heat.
Sound.
Little bit heat. Not all of them transfer to heat.
Okay. Very good.
Okay, these are all of the correct answer. Okay, next problem. Isaac, you wanna read the next problem?
Cool. Have him do this one.
Huh? Oh.
Have him do this.
Oh, okay. What is it?
Oh no, it's an electricity problem.
Okay, yeah. Isaac, I'm gonna write the problem. Here's the problem. Isaac, read it.
All right. A battery with a potential difference of 12 volts causes 0.6 amperes to flow through a circuit which contains a bulb and a resistor connected in parallel. The lamp is operating with a power of 6 watts.
No, at 6 watts.
Same thing.
Hold on, don't fight. So what I want you to do over here, I'm gonna write VIP at location 1, location 2, and total. What I'm gonna give you 0.6, and what I'm gonna give you 6.
Also 12
And
volts.
I'm gonna no.
Yeah.
No. He will do it. I already give him.
Oh.
This is location 1. This is location 2. Isaac, go ahead.
All right.
Good luck. This is probably the most challenging problem.
So we're going to.
You're gonna complete the table.
You need hints?
No, the reference table is everything I need. Okay. So I'm pretty sure this one is 12, right?
Sure. Okay.
Sure. All right. So for a parallel circuit, what's given is that the total current
What is
the current
what is
1.
voltage at location 1 and location 2?
Okay, give me a second. Current is the sum of the current at every resistor. So in this case, it's I1 plus I2.
This is parallel or series, Isaac?
This is parallel equation.
Okay, good.
I'm literally getting it from the reference table. This can't be wrong. So this is true, and then 1 over R total is 1 over R1 plus 1 over R2. So these are the parallel equations.
So first, and also this is not T. This is equivalent resistance. What is equivalent means? Can either of you can help me understand what does
Total
equivalent?
resistance.
That's
No,
the same thing.
it doesn't mean total resistance.
If you replace those two
That's
resistors
right, that's
with one
right.
resistor.
That's right. That's what it means. Okay.
Yeah. All right. So this one is also just 12. This one is. Why do you
No,
have
they
to
are
make
12.
It's a test.
Who asked? Who asked?
12 apples or oranges?
No, we are not joking
or
here.
both.
No.
I don't know. He didn't
No,
know.
you don't have. They're gonna get so messy. No,
Okay.
don't need to write the essay unit.
All right. So now we're going to use this thing known as Ohm's triangle. So we have voltage, current, and resistance. So whenever we want to find the formula, it's like we break off one piece of the chocolate candy. So in this case, if we wanted to find the formula for resistance right now, we break off a piece of this chocolate candy. This is resistance, and this is V I.
Okay. Sure.
So R is V over I.
Okay.
So in this case, we can say this for the total resistance.
Yeah, you can do whatever you want. It's a free country.
Okay. So this should be 20 ohms.
Yeah, that's true.
Really?
No, it is 20. No, it is 20.
How did you do that? Can you?
Yeah, that's right.
R equals V over I.
Okay, plug in the V and plug in the I.
Are you dumb? Oh no, let's not stigmatize questions.
Oh yeah, no question is a dumb question.
Except we've asked questions.
Okay, that's true. Now, all those missing values.
All right. Now let's fill this in. So we have a couple equations for power. So power is VI, I squared times R, and V squared over R. All of which come from our little chocolate triangle. So in this case, let's say we want to use the formula power equals V times I. So then we just use 6 is equal to the voltage at that point, 12 times I, or I equals 0.5 amps. Wait, no. Okay. So now, through this formula, we can deduce that this one is going to be 0.1 amps.
Everything is right so far.
So now, we're going to use this formula, P equals I squared R. So what's that going to give us? Well, 0.5 squared times r is equal to 6, or r equals 6 over 0.25, which is 24 ohms.
That's
How
correct.
did you know that without calculator?
6 over 0.25, 6 times 4.
That's
Oh.
okay.
You must be dumb.
Again, no question. Teacher, make sure that
Well,
you
I'm not the teacher here. I'm just a student presenting. That means I'm free to say anything I want.
okay.
All right. So
One
yes,
day when you're gonna become teacher, you have to watch
and
your
that's why I'm
mouth.
never going to become a teacher. I want to yell at my students all day long. Okay. So 1 over the equivalent resistance, which is 20.
Well, you can do the same thing. It'll give you
Ba
faster.
ba ba ba
It'll
ba.
get you the right answer faster. Just 12 over 0.1, which is 120.
Sure. Genius. How'd you know it was 120?
Because it's over 0.1, so you add 0.
Oh wow, revolutionary.
All right, Isaac, you have still two more unknowns.
All right. So P equals V times I, which is 1.2, and again P equals V times I. Don't pick up the ruler, and it's 7.2.
All right, with all the values, it seems like you have too many values. 3 times 4, 12 values. Which one is the correct answer out of 12?
Yeah, which one?
Wait, what do you mean by
You're not
the
allowed to see the question.
what? Okay, calculate the current through the lamp.
No, okay, sure.
We know.
Let's see.
That's not
Oh
even.
wait, no.
That's not the lamp. That's not the
No,
lamp.
hey, shut up! The lamp is the one with the big arrow pointing with the name lamp, and the one which we know the power of.
Oh, that's
So
the power?
Yes.
That's the
Power
power.
is given.
That's the power.
Yes.
But what is it saying?
Yeah, we're finding the freaking current. Just give me 1 second, man. Do you talk like this to your professors? Because if so, surprised you haven't been kicked out yet. Okay.
Okay, so write the current.
All right.
That is what you're trying to find, right?
76 to 77. Calculate the current through the lamp. So it's going to be boop, boop, boop,
So write down on the lamp.
0.5
amps. Good.
And
Answer
here,
the next question.
determine the current in this resistor. So that's just going to be boop, boop, boop,
Write it down.
0.1 amps. And finally, calculate the resistance of the resistor, which is 120 ohms.
Did you say amps in the beginning?
Shut! This is why no one likes you.
I do.
Yeah, right. 1 through 85.
Oh, really?
Yeah.
Is
Yeah.
No, shut your mouth.
Okay.
I can.
Fine.
He's gonna do one way, you're gonna do other way. Coin toss.
Okay. The Great Nebula of the constellation Orion consists primarily of. Oh, our teacher left.
No, read. Keep reading.
Consists primarily of excited hydrogen gas. The electrons in the atoms of excited hydrogen have been raised to higher energy levels. When these atoms release energy, a frequent electron transition from the excited n equals 3 energy level to the n equals to the n equals 2 energy level, which gives the nebula one of its characteristic colors.
Okay. All right. So what happened is, Raf gonna toss the coin because you don't know how to toss the coin.
What?
Yesterday, you took half an hour to tossing the coin.
But tossing the coin
And
almost
the coin never land on the table. Never. Okay. So.
Okay, fine.
And one, Isaac. What is E1 quickly?
E1 is Ruga Ruga. Minus 13.7 goddamn 6.
Sorry. And 2, Isaac.
3.4.
Minus 3.4.
Heat heated.
And 3, Isaac.
Minus
0.85.
Minus 1.5.
1.
And infinity, Isaac.
0.
Minus 0.85.
No, he said infinity, you blind man.
The electron is here, and Isaac, electron jump over here. Okay. If electrons jump over here, electron lose energy or gain energy?
Lose.
And electron release, what do you call it?
A photon.
This photon has a color. It's a light. We human perceive that as color. You want to find the color. To do that, you're gonna, if you win the coin toss, then you can You have a freedom.
So you mean like the flipper? All right.
Okay.
No.
Can I see the face of the
Okay.
coin?
What you want, heads or tails?
All right. I'm gonna go tails.
Okay.
Go on.
Tails.
Okay.
Ha.
Go.
See, I told you the flip side of whatever's up wins.
Solve any way you want. At least he didn't take half an hour to do the current task.
Okay.
Go
So-
make some mistakes.
I thought this is a class, physics class.
Teachers aren't allowed to hit their students anymore, but other students sure are. Okay. I'm just kidding. Don't hit your fellow classmates. Okay. So I'm gonna go looking for the freaking. Okay. So what's the right?
By the time he finished the training to become teacher, he'll be fine.
Is it like this
Not
equation
gonna
again?
make it through. Check the reference table.
It doesn't happen, I think.
If you want to do this one, then you have to do HCR. Then you have to write
H?
HCR.
What?
H for Planck
I
constant.
see. Okay.
All right. E is equal to,
Sorry.
and R subscript H.
Yeah, and you know what HCR is already.
No, H. Okay, good. Yeah, good.
You know what? Let me not tell
Alright.
you. So you
Oh,
may-
shut your
No,
little
HCR is
trickly-
2.17
Yep. Okay.
times 10 raised to negative 18.
Okay. And then you get 1/4 minus 1/9 from this, which becomes.
We can help you with that, or you can do the. No, you can. 36 is the LCD. Come on, you just.
Oh, you want me to?
But he has to calculate that.
Okay.
But he has a boo blah blah. Boo, boo, boo,
5 times
blah.
2.17. Any fast grader knows it.
Any first grader knows it. 20 minutes later. Help, mommy! I can't solve this.
How did you get 5 here? Let's see. 9 minus 4. Okay, good.
Man cannot do basic subtraction of fractions. How did you get this far?
Yeah, that's an open question.
The hardest question in all of physics.
Okay, 5/36. Okay, the whole thing is 3 times 10 to the 19 minus 19.
3 times 10 to the
Negative
negative 19. But
Now what do you have to
Joule,
divide by?
Joule. No. He gonna do that.
Okay.
So this is Joule.
So then we know that E equals HF.
Can you use different colors so it doesn't mix up?
Okay. So we
He
get.
won the toss and he chose the hardest way of doing it.
Yeah.
Yeah, I want to make it easy on my little moron.
Okay, sure.
Okay. All right. Didn't know there was an easier way of doing it actually, but we have the Planck constant from the reference table is 6.63 times 10 to the minus
Do you see
34.
the easier way?
Okay.
So what's this?
4.5 times 10 raised to 14.
1.8.
4.5. 4.5.
Let me see.
It's 4.5.
He's getting
Oh,
1.9.
No. He doesn't know what he's doing.
Of course he doesn't.
Just 3 divided by 6.63. Just 3 divided by 6.63. Do 3 divided by 6.63.
Why are you stuck?
0.45.
Yeah, so write 4.5
Wow, you really are a special specimen.
times 10 raised to 14.
Okay.
1 over second. Or hertz.
All right.
Alright, now write F.
Okay.
Write F. No,
So-
in the middle. Write F.
What?
F is over there as well. Put F there.
Okay.
Now write F in the middle of the board, okay? Write F is less than 4.8 times 10 raised to 14 and greater than 3.8 times. If this is the case, then what is F?
Red?
Good.
Bro, I didn't even have to look at the reference table. Well, we all know you cheated. No, I'm just kidding.
Okay, my turn.
Okay. So you know which way you're doing.
Yeah.
All right. So this one minus this one.
Yeah.
Okay.
Okay.
This one minus this one. Yeah, that's the kind of basic guidance you need.
Okay, can I erase the...
Yes, you
Yeah,
can.
yeah.
Don't you call my work mistakes.
When did I do it?
Just now, Mr. Gaslighter?
Okay, folks. So let's take a look at the solution. First, all we have to do is calculate how much energy the electron lost as it jumped from N3 to N2. Okay, so what we have to do is E3.
I don't know why he had to bring the right bar constant.
Yeah, E3 minus E2. Well, as we remember Einstein's famous quote, the ones who don't understand always complicate things.
Oh, shut up!
Minus
Wow, 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 wow.
1.51 minus 3.4 electron volts. Okay, if I do this math, then I get 1.89 electron volts, but I need my answer in joules, so I will multiply this by.
Can you guys do it nicely so students know how to convert
Yeah.
the unit?
So
1.89 electron volt times
times
electron volt on the bottom.
Okay.
Minus 19 joules.
Yeah, the electron volt.
Congratulations.
So this is 3 times. This is 3 times 10 raised to negative 19.
No, let him calculate. Let him waste some more
This
time.
is 3. 19 joules. By the way, the reason we have joules is because these cancel out.
The Regents will accept it if you just rammed it to 3.
So this is
Energy.
our, yeah, right. So this is our change in energy, which is equal to HF. So that means our frequency.
And now it just merges with the other path.
This one.
Yeah, that's true.
Wow. So you understand that part, right?
Rivas, you had to be reminded that we were solving for energy again.
34 joules.
Even if I'm dumber than
sorry,
you.
not joules.
You have.
Joule second.
You've got.
Second. So, doing this.
4.5
Yeah, 4.5.
You can't even remember this value.
times 10 raised to 14.
Minus 14?
No, plus 14.
Plus 14. Right?
14 hertz. Because if it is minus 14, then it wouldn't be red.
That's right. That's right.
How did he get this far?
So this is red.
No, he's pretending so that his student
He
understands.
does research on light and he can't remember.
He's pretending. This is called keeping low profile. Solved Regents 2016, 51 to 85.
Yeah.
Which problem was most challenging and rewarding, you feel like?
I think it was 75 through 80, the circuit one.
I agree. I think the circuit problem was difficult, especially for my colleague here.
Second challenging problem.
Let me see.
No, without looking at it. If you have to look at it, then it's not. It was not.
I'd say the one likely to trip up the most people was 56 to 58.
Or
The ball rolling off the table.
At the same time.
No, maybe the airplane one. The airplane one.
But that one's more straightforward. There aren't major.
What about the light one?
No.
Yeah, line one also. That one is also tricky. Yeah.
All right.
No, you're just bad. I'm just kidding.
Okay, so what one thing that you discovered today, because every lesson if you don't discover anything, then it has been a failed lesson. What did you discover today?
So today we discovered many things. Almost every single concept in Regent physics we reviewed. But I think the best thing we did, the most extensive and comprehensive thing, was the circuit problem, where we remembered about using that table to calculate V, I, R, and P separately, just like we did a long, long time ago in one of the first few physics conversations.
Yeah, I agree. The circuit problem tested a lot of the concepts we learned from E&M, and such as Ohm's law, the different formulas for the power, I squared R, VI, and so we got to use all of that, and we saw what a correct solution looks like.
These two are scholar. One is from Brown University, one is from New York University. Although they have wonderful skill in physics, but they were willing to be my student to solve some Regents problem. Sometimes you learn big thing from easy problem.
That's a profound quote.